So this will be the first video when I'm explaining what I'm doing. And this is the device. This is TR6120A programmable DC voltage standard. And this is how it looks when I got it just from Japan auctions. The price was about $160 US. And the first thing that I will do, I will just inspect it and try to figure out what is happening with it, and then we will try to repair it. And I will be explaining everything, what I'm doing, all the steps, so please stay tight. So as you can see, the cosmetic condition of the front panel is almost ideal. Of course, it has some small scratches and bruises over the housing, but actually the front panel, it looks like it was not used. That's what I like in these Japanese devices. Sometimes they are in really great condition. But what the first thing that I see is it has this weird modification. I wonder what is inside. Maybe it doesn't have any boards at all. Maybe it was modified at some time. This was a mystery, but anyway, the price was $160 US. That's just without the shipping and the taxes. The taxes was about $50 here in the Poland, and the shipping in the boat, in the container ship, was $50 and the time delivery was 3 months. Anyway, I think it was a good price for this device, and it's one of the first devices that was using PWM modulation to generate the voltages in the same and a similar way as the Fluke uses. And it would be very interesting to investigate the schematic and learn how it works and take a look at the boards inside and overall the culture of manufacturing of the Japanese metrology devices, especially of this level. So yeah, stay around and we'll continue. So looks like everything is intact. All the boards are on places, and except this little modification here. And I will not turn it on right now. I will check all the boards for the bad leak capacitors, check power supply for the shorts. Only then I will try to turn it on. This is my way to work with these devices. I always check everything before turning them on, because after standing in a power off state for such a long time, the issues might accumulate, and when you give it the power, the situation might be even worse. You might burn something, so you need to check carefully first for the caps, at least the tantalums, and so on. So we'll continue soon. Okay, so the first problem that I see are these buttons. They are completely stuck. I cannot press them. This modification, these switches are probably to compensate that. So how nice that they didn't try to fix them. So this is how the device looks at the bottom. And it has a lot of these niobium electrolytic capacitors, which should be checked as well. Well, I just found the reason why this switch is not working. It just lost its spring, the back here. So I will try to come up with something. And also, I noticed that these switches are all stuck. It's almost impossible to turn them. And they're moving like they glued to something. So I need to service this as well. I probably all of this also. Thought that this switch is just a micro switch that lost its properties because the spring has broke. So it's no longer clicking or making contact, and it's not repairable. It's completely sealed, hermetical one, so you need to buy a new one to repair it. So here's the latest update on the switches. These ones turned to be good. They actually do not have any oxidation. The contacts are white, and as I looked them a little, and they are switching fine. And the resistance is measured, it's about 100 milliohms. Same for these ones. Despite being completely black, covered with patina. They actually measure like half a ohm when connected. So these ones are also good because they probably just scratched out their own oxide layer. But then we have a problem with these buttons. They actually measure it like 9-8 ohms when switched, and then when you switch them on, it's a lot. So I think we need to clean these ones as well. So I've been measuring the electrolytes and I found a few bad ones. So all the usual liquid electrolytic capacitors are measuring fine, but these small niobium ones, they are measuring incorrectly. So this one shows 5D, which is very high. It should be less than 1. And this one shows very low capacitance. It should be 22 microfarads. So I have to desolder and measure them again. So to fix these buttons, I'm probably gonna salvage these ones, just the two of them, because I don't use these ones oftenly. These ones are used for programming, and there are in total 14 programs. I will just use 2 last buttons. And this will allow me to save the same click and feeling for the enable output button and standby buttons, which are used very oftenly. While these are almost don't used, I'll still replace this micro switches here, but that I will do that later when they arrive from the shop. But while now I'm just gonna move these two here and everything will be okay. Okay, first time turning it on actually. And obviously this is 100 volt device, so I'm using the transformer because this is in Poland. So here's the transformer. Okay, let's go. Okay, obviously I need to turn on the transformer itself. Okay, it's alive. At least digital pulser is working, I hope. Yeah. Okay, it's in standby mode. Let's press separate. Wow, it's working. Look at this. 1, 2, 3, 4, 5, 6. Awesome. $10 volts. Okay, let's give it 130 volts. Wow, it's working. Okay. Awesome. Okay. Now let's give it a 1000 volt. Just build it like this. Okay, so this one's not showing anything. Probably I should press separate. It goes into limit. Okay, let's limit to 1030 volts. Okay, and it's working. Awesome. Okay, so as you can see, the current ranges are also working. And the noise of the fan is pretty low. Actually, it sounds almost like a new one. Also, it has a very interesting feature. When you move one of these 3 knobs to the continuous mode, like this, you can adjust the output more precisely. I mean, not more precisely, but just kind of slowly. I have no idea what is the purpose of this, but might act like just a power supply or current source, because at the At 10 volts it has a 130 milliampere limit current, so it's pretty powerful one. So the most major usability flaw that I see is actually it doesn't switch off its output when you go to high range. For example, now it has like 8 microvolts, and when I go to 1000 it just continues operating. It should go into standby like all the calibrators do, at least the Fluke does that. So, but that's, you can fry anything by just switching the mode here, and the positions of these knobs is kept. So yeah, that's not great. It should go to standby immediately. So the interesting feature that it has without the microprocessor inside, actually the memory function. So you can go to the memory setting and then just set your desired voltage. Press 1, it's remembered. Press 2, it's remembered. Okay, let's go to, actually, then press 3, it's remembered. 4, 5, 6, okay, and then you go to recall home, and with 1 second interval it will output the voltage that you configure here, and it will run all through these 14 programs. So let's press initiate, and you can see you can go through each voltage, and if you can enable, you can see that on our voltmeter. So yeah, simple programming from the front panel without GPAB and other stuff, but it has remote control, but obviously not the GPAB. Okay, so let's break down about what I have found until now. So as you can see, the zero needs to be adjusted because the Datron has, when its inputs are shorted, about 100 nanovolts level, and now we can see about 180 microvolts, so that's too much. Of course, everything is connected correctly, so I'm using the guard functionality of this calibrator, and the guard is the shield for high and low, and it's connected to Datron guard as well, and Datron guard switched to remote. Also, the sense connection is connected here, and it also guarded. The shield is guarded with the same guard potential. So right now we should see 0, but it is not. Let's switch to the positive 0, and we can see the same thing. And what about this? Yeah, so you can see that it's similar but in the negative polarity.